A mangrove restoration team is sitting across from an international carbon credit verifier, ready to present their final data. They slide their report across the table, proudly highlighting their total ecosystem carbon stock. The number is exactly 500 megagrams of carbon per hectare. The verification board rejects the project on the spot. The reason? The number is a single, precise average. In climate science, all physical measurements contain inherent, unavoidable variations. Presenting an exact average without an accompanying margin of error is considered misleading. What policymakers, donors, and credit verifiers actually demand to see is a 95% confidence interval. Presenting a single perfect number fails to project accuracy. In the complex world of environmental science, it destroys credibility. To understand why finding a single perfect number is impossible, we have to look at the physical environment of a dynamic ecosystem.
We measure this environment using the total ecosystem carbon stock, or TEX. This metric is the sum of all significant carbon-holding pools within the habitat. The first measurable pool is the above-ground biomass, which consists of the highly visible trunks, branches, and leaves. The second pool is the below-ground biomass, representing the complex, tangled network of roots. The final, most crucial pool is the soil organic carbon. Notice how the hidden soil layer in this cross-section is measured down to 100 centimeters, containing 70 to 80% of the ecosystem's carbon. Because the vast majority of a mangrove's carbon is buried deep underground, it cannot be perfectly counted. Any single exact average is mathematically flawed. For the field researchers gathering this raw data, every physical measurement comes with unavoidable variations. Wrapping a tape measure around a muddy, uneven tree trunk might yield a tiny 5% measurement error. That slightly off measurement is plugged into an allometric equation to estimate volume, introducing model error that balloons uncertainty to 12%. Scaling that single plot to represent an entire hectare compounds this further, pushing total error past 20%. Statisticians handle this compounding chaos using a technique called Monte Carlo simulations. The process involves running the carbon calculations thousands of times, introducing random variations within those known error ranges every single time. This visualizes the simulation's output, a probability distribution. The dense clustering allows scientists to draw a 95% confidence interval. Returning to the original data, it reads 500 plus or minus 120 megagrams per hectare. We are confident the true value lives inside this range. By mathematically embracing compounding errors instead of hiding them, scientists transform a weak guess into a robust, defensible claim.
These statistical requirements are enforced directly by international carbon market verifiers like Verra and the gold standard. The financial stakes are strict. If a project's relative uncertainty exceeds a 20% variance, the issued carbon credits are actively discounted, resulting in a massive loss of financial value. Successful environmental restoration requires intense ecological labor, but it also demands rigorous, transparent accounting to secure the necessary funding. Human nature prefers simple, definitive numbers. Complex living ecosystems refuse to be reduced to a single data point. In global climate policy, a 95% confidence interval is the foundational currency of trust.